So our last panel for the day, we're saving the best for last. And we knew this would be a contentious issue when we started the study, is forest chemicals. And here we're going to look at Dr. John Souter will come back, the forest watershed specialist and professor from the firm department is going to talk about, assistant professor, I should say. I don't want to promote him. I don't have that authority. Should be a professor. Is going to talk about the science behind the chemicals chapter. And then we're going to have a forester. We're going to have actually a state forestry forester, a forest practices person, Jay Walters, and then a forest on the ground forester, Whitney Henneman. And we're going to finish up the last in the panel will be Carl Morgenstern from eWeb. So Dr. Souter, turn on your camera and turn on your
All right.
PowerPoint. Here it is. Take it away, John.
Okay. All right. Thanks, Mike. Good to be back again. Like Mike said, we were uncertain about how this breakout was going to work, and it did seem like it worked really well. So what I'm going to do now is do a fairly high level walkthrough on the forest chemicals chapter in the Trees to Tap report. As Mike said, it's a fairly involved chapter. It's 50 pages. I have 20 minutes, so that's 2.5 pages a minute for it or so. And so part of the involvement with it was just the mass of material that was available with it. So as part of the literature review that we did that Jeff Behan led, we uncovered 114 articles and reports related to forestry and forest chemical use. 96 of those were peer reviewed. And there were also 4 databases for chemical properties that my co-author Bogdan Strimbu used to look at the chemical properties of these typically herbicides that are applied. We also looked at almost 12,000 chemical notifications for that 2015 to 2018 period. And in those 12,000, almost 12,000 notifications, there were almost 30,000 activities and 222 chemical formulations named for that. We did in-depth reviews of 3 of those peer-reviewed articles, all from Oregon. And then we looked at 4 agency monitoring projects, and each one of those projects typically had at least a half a dozen reports associated with it. And then finally, we went through the incidents and complaints that the state received over forest chemical applications in the period from 2013 to 2019. And that involved 140 of those reports. So that was the foundation for the work that we did to put this chapter together. One of the early observations that we made is that in contrast to a lot of chemical applications on land, particularly on agriculture land, the pattern of forest chemical applications is very different in that there can be some applications prior to harvest if there is competing vegetation in the understory that the forest manager thinks is going to blossom after the area is harvested. Then they may go in and treat that prior to harvest to prevent that from getting out of control. You'll have a harvest. After the harvest, there's typically a site preparation in conjunction with a replanting for it. The planting occurs. There may be up to 2 tree release sprays, typically aerial sprays after the planting is done, 1 to 2 years, and a second one if needed, 2 to 5 years afterwards. If there's a likelihood that you've got potential damage to the seedlings from small mammals or from mountain beaver, there may be rodenticides used during that period. And then things basically stop in terms of chemical application until If there is a pre-commercial thin at year 7 to 15 or so, there may be some fertilization after that. If there's a commercial thin at years 20 to 30, there may again be some fertilization after that. But it's very unlikely that all of these applications are going to occur on any single piece of land. So when we looked at the notifications, we divided the types of notifications into used ODF's categories, divided them into these various different classes in there. And it looks like there's about 8 classes in there for notifications. First of all, there were very few fungicide and insecticide applications in this period, again, from 2015 through 2018. So there was less than 400 acres of land over that period of 4 years that had any fungicide or insecticide application to it. So we really just did not end up emphasizing that for it. We did look at fertilizers because that's a fairly heavy use in terms of acres. But we really focused on the unit herbicide applications because that was almost 4 million acres, or a little bit less than 1 million acres a year during this period with it. And then as we heard, I believe Paul Newman mentioned it during the Oceanside case study, any one of these notifications can have multiple chemicals associated with it. And so part of what the analysis of the NOAPs that I did was to figure out for any given notification or any given activities in a notification, how many chemicals were notified for that. And the bulk of them had more than one with it, and that's typical, and we'll talk a little bit about that because there's typically an active ingredient and then there will be a surfactant associated with that or some other what's called an adjuvant associated with that. And so the bulk of the NOAPs have, probably 6 or fewer chemicals mentioned in them, but there can be some of these notifications that have, fairly large list of chemicals with them. Up to 21 was the highest that we found, and a number of them had 20 chemicals in them. And as we've talked about this, a notification essentially can last through an entire calendar year. So you have the possibility in some of these cases of having large numbers of chemicals that could be applied over a large period of time for it. So then after that, we looked at, which of those chemicals were being identified in the notifications in terms of percentages in those notifications. And so, clearly there were about 5 that were in the top there, glyphosate being the biggest one. And that would be, Roundup, Rodeo, Accord in there. We've got sulfametron methyl, which is oust, is the common trade name for that. We've got trichlopor, which is probably the most common commercial name for that is Garlon 3A. Imazapyr is arsenal or cropper. Metsulfuron methyl is escort or open site for it. And so those are the bulk of the chemicals that are in there. We also have, like I mentioned, in most all of the notifications have more than one chemical, and that typically includes a surfactant. And the role of the surfactant is to help that active ingredient stick to the plant that it's associated, that you want to target for it. So it helps it stick to the leaves with it. And then you've got other types of additions to the spray mix that help the application and increase its effectiveness. So you've got about half a dozen different types of adjuvants in there, and you have a considerable number of products for that. It's also useful to know that the adjuvants aren't registered with US EPA the same way that active ingredients are, or the same way that the commercial formulations are. So there's a lot less information on what is contained in the adjuvants than there is in what's in the active ingredient formulations. So when we look at the characterization of these active ingredients, there's really 5 different characteristics that we're interested in, or that affect how they move through the environment for it. One is their mobility, and that's really characterized about how strongly they attach to the plant or attach to soil with that, and that relates to the electrical attraction between the chemical and the plant or the soil. So you have some of these chemicals are mobile, which means that they don't have a strong attraction to the plant or the soil, and so they readily can move from it. Other ones are non-mobile, like the case of glyphosate here, which means that they're strongly attracted to the plant or to the soil, which is good if the soil stays in place. And if the soil doesn't stay in place, then that particle of sediment with the chemical attracted to it goes into the stream and goes downstream and gets into the treatment plant. Another important characteristic is how soluble the active ingredient is. And basically, does this active ingredient dissolve in water? And the more soluble it is in water, the further it's likely to travel with it. Volubility is whether it tends to evaporate after it's been applied, and if it does evaporate after it's applied, then that can get into the wind patterns and result in drift that ends up in the stream. Luckily, most of the common chemicals used in forestry have a very low volatility. And then another these final 2 characteristics really relate to how quickly the chemical breaks down. And one is how quickly it breaks down in water or in sun, under light, in water. And that can be stable, or that can be break down very quickly for it. Another characteristic, and this has really been more important in the insecticides and fungicides, is how persistent it is in the soil. So if it breaks down in the soil rapidly, i.e. it's non-persistent, in the case of non-persistent, half of it breaks down within 12 days or so. So you get a fairly quick breakdown into the soil. And in most cases, that once the chemical is broken down, it's not going to be toxic. That's not always the case for it, though. So when we start looking at the regulations, and Josh mentioned this in the Oceanside case study, and Paul did as well, is that there are certain chemicals that are regulated in terms of their allowable concentrations in water. And that's called the maximum contaminant level, or MCL. Well, it turns out that there's only 3 of these chemicals that are regulated, and that's 2,4-D, atrazine, and glyphosate. And so those are the only ones where there is a definite violation of water quality standards if you have concentrations above a level set by US EPA. Then you have a whole nother set, essentially, of standards and benchmarks that are kind of non-regulatory, non-enforceable. So you have these goals that are set that depend on human health, not having human health effects. You have health advisory levels for it that are dependent on how much a person consumes and how long they're exposed to that. You have a more general human health benchmark. And finally, there are aquatic life benchmarks that tend to be quite a bit less even than the human health benchmarks. And so we'll see in a lot of the studies that I'm going to review next, that the human health benchmarks and the aquatic life benchmarks are typically how the results are reported in these studies. So we have levels of analytical reporting. So if you have a fairly substantial amount of a chemical in water, that samples are reported in the concentrations, whether it's milligrams per liter, micrograms per liter. A lot of now sensitive testing reports in nanograms per liter for a billionth of a gram in a liter. You also have a minimum quantifiable level based on the test. At what concentration in the test is it? Can you reasonably quantify the result? So what's the lower bound that you can quantify it? And then you have a minimum detection level, which is you can detect it, that it was there, but it's not quantifiable because it's in so low concentrations. And then the minimum quantifiable level and the minimum detection level really depend on the methods that are used for the test. And then as was shown in the Oceanside case study, you have both grab samples that are taken at a given period of time, either just physically going out and pulling water out or having an automated machine. And you also have these continuous recorders like Oceanside used that are based on a resin that holds on to any of the chemical that's going through the water in there. And then you take it out after a given period of time. And that will give you a reading on how much of that chemical was in the water over a period of time, day, week, month, or multiple months for it. Okay, so I mentioned that we had 114 studies and reports that we looked at, 96 peer-reviewed reports. Turns out that there were only 3 of them that were really very pertinent to the Pacific Northwest and to forestry. And so there was one report on the Coast Range that was done west of Philomath that was actually was focused on evaluating drift with and without riparian buffers and different intensities of wooded buffers for it. There was a second study that was also done west of Corvallis as part of the ALSI Revisited study, the paired watershed study there, that looked at a unit that had both small fish and small non-fish streams, and the non-fish streams didn't have any wooded buffer in them. And as John Wehage talked about, there was the Caldwell and Corder study in the Tillamook area that evaluated operations in small fish, small medium fish streams, and non-fish streams. And they had 3 units there that were sprayed over 2 different years in a control. And to summarize it, really, it was evident in all of the studies, and particularly the 2 studies that had the chemical applications, that in these small in streams without buffers, there were chemicals that were reaching the stream through drift or overspray with it. And as I think Paul Newman talked about, in the first couple of winter freshets also delivered chemicals to streams. But there was really no pattern other than the fact that it was really only the first couple of storms that delivered this material. The specific chemical varied from one stream to the other stream and one study to the other study. So it really wasn't possible to establish a pattern to what was going to move and what wasn't going to move in there. And then with the exception of one glyphosate application, and it wasn't really even clear if that was a legitimate kind of reading for it, no concentrations exceeded regulatory levels, and almost all were less than human health benchmarks, and typically by orders of magnitude. And so we had a lot of that minimum quantifiable levels, everything that was detected or met the minimum detection level if it was reported as a result. But there were a lot of a lot of these samples that were below the minimum quantifiable level, which meant that they were in the nanograms per liter for it. Had the kind of same pattern with what I'm calling the agency reconnaissance studies, and there were 4 of those. 2 of them were parts of the pesticide stewardship partnership that Oregon Department of Agriculture has that and ODF participates in. There was one in Hood River that's had quite a bit of work done on it, largely because of the concentration of orchards there and the spraying that occurs in orchards. But there were some sites that had largely forested areas above them, and so I pulled that data out on those sites. Similarly, with the South Yamhill River, there was also a larger part of the study, but there were watersheds that were essentially just forested. Washington Department of Agriculture had a study in the Hoh River with the Washington DNR, and then there's the Eugene Water and Electric Board studies on the McKenzie River. I think Carl Morgenstern later in the panel is going to talk a little bit about that. So we were looking at these sites focused on streams that drained forest lands with active management. The sampling typically occurred at the bottom of a stream system, so you had a larger watershed with it. A lot of times it was unknown about where the applications were occurring, the timing, the chemicals applied, and typically there were no samples taken during storm events. And in most cases, the sampling was grab samples rather than the continuous samples. So again, we saw some chemicals that are used typically in forestry were detected, less so in the McKenzie River studies. But again, none of those concentrations were above human health benchmarks with it. So they're small concentrations, but they're clearly getting into the water streams. Okay, so what happens when things go awry and people get concerned about it? So there is this organization called the Pesticide Action and Reporting Center, PARC, that is set up to receive and investigate reports over chemical applications. So somebody can make a complaint or ask for an observation from any of a host of various agencies, state agencies with it. These agencies have standard operating procedures with PARC about how they're going to take those complaints. PARC puts together an investigative team. Typically, ODF looks at the operation. ODA checks whether a label was followed. If there was an employee exposure, and that has been the case in a situation or two, then ORSHA gets involved. If there's a finding that violations occurred, then the agencies can take enforcement actions, and then PARC goes through these reports, puts together contributing factors, and those are rolled up into their annual reports. So we looked at 140 of these, and these were a little over 3% of the total incidents reported to PARC over this 6-year period from 2013, 7-year period actually, from 2013 to 2019. Interestingly enough, that's the same estimate that we have on the amount of the proportion of chemicals used in forestry compared to the total chemicals applied in the statewide. Most of the complaints or the incidents related to aerial applications, some on the ground and a few on right-of-way. Now, almost half of these observations, or 42% of these observations or referrals to PARC, were a request from the landowner to have ODA and ODF come out and observe a spray operation. And interestingly enough, these seem to be concentrated around Triangle Lake, to no surprise for it. So in this case, ODF goes out, ODA goes out, observes the operation, and then submits a report back to PARC from it. About a third of the complaints, or about a third of the incidents with park are in fact complaints over application. Those are mostly over drift. There were a few that were right-of-way spraying. The county comes through and sprays the roadside and kills your best rose bush as a result, and you file a complaint, or there's some spraying and they spray into the stream as a result of that. So over the course of these 7 years, there were 6 violations for forest chemical use, 3 letters of advisement, which was basically a warning letter from the state to the applicator. 1 license was revoked. That was the Gold Beach incident. And there was 1 2-year suspension, and that was the Appleby aviation case for that. So we're seeing a kind of amount of complaints that are proportionate to amount of chemicals used in forestry. But we're talking about, in terms of complaints, we're talking about probably 50 complaints or so, or 10 or so per year about forest chemical applications in forestry. So that, I think, sets us up for hearing from the panel, and I'll be eager to see what comes out of that.
Excellent. Thank you, John. It's incredible stuff. To think of all the digging through all of those NOAAPs is just incredible. This is a real gold mine. So next up, we have Jay Walters, and Jay is with ODF, Forest Practices Field Coordinator and an excellent fellow. So tell us what the Forest Practices Act has to do with all of this, Jay.
Thanks a lot, Mike. Let me get my screen ready to share here. All right, are you seeing the intro slide?
Yes, it looks perfect.
Perfect. Awesome. Well, thanks again for inviting me to be here today. My name is Jay Walters, and I am a Forest Practices Field Coordinator with the Oregon Department of Forestry in Salem. My job is to help support, provide technical support to about 50 stewardship foresters statewide. And stewardship foresters are the frontline ODF folks who administer the Forest Practices Act and its rules. All right, here's what we're going to talk about today. I'm going to give a brief introduction to the Oregon's Forest Practices Act. If you hear me say FPA, that's what I mean. I'll talk a little bit about its scope. I'll talk a little bit about water classification and how that feeds into water protection measures. And then if Mike doesn't get out his shepherd's hook, I'll touch on communications just a little bit. So Oregon's Forest Practices Act was adopted by the Oregon legislature in 1971, and it set resource protection standards for commercial activities that take place in the forest, including road construction, timber harvest, site preparation, reforestation, and the use of herbicides and other pesticides. These standards are all designed to provide protection for the resources and values that we all enjoy and get out of the forest. Clean drinking water, fish and wildlife habitat, soil protection, forest productivity, and public safety is in there as well. The FPA is updated periodically based on new science and social values, including Senate Bill 1602, which you may have heard about recently. The Senate bill grew out of an agreement between the timber industry and environmental interests to update stream protection standards, as well as to set the stage for mediated discussions to provide longer-term updates to state standards. The bill was signed into law in July of 2020 and is the most recent update to the FPA. So the resource protection rules and standards under the FPA and its administrative rules apply to commercial forestry activities on all non-federal forest lands in the state. So on this map here on the screen, That applies pretty much everywhere except for the orange, which represents federal lands, and purple, which represents tribal lands. And the rules and standards apply regardless of how the land is zoned or taxed. So that said, there are a number of cities that have their own tree ordinances that ODF has reviewed and deemed to be equivalent in protection to the FPA. So that was the scope of the FPA. So let's switch to water classification. So ODF classifies waters of the state into one of three big buckets: streams, wetlands, or lakes. Those three different buckets are further refined by beneficial use, domestic uses, use by fish, or none of the above. The domestic use includes both individual water systems as well as community water systems. Classifications are further refined by size, small, medium, and large, and the beneficial use plus the size dictates the protection. So that protection translates into riparian management areas for timber harvests and to buffers during the application of chemicals. Classification is a whole bunch more complicated than this, with a fair amount of slicing and dicing between different classifications, but these are the generalities. And the breakdowns we're going to talk about here are for streams. The other two buckets, wetlands and lakes, they do have similar breakdowns, though they're not quite as complex as those for streams. So waters of the state, including streams, receive protection by way of no direct spray buffers. And the width of these buffers varies by the application method. So ground-based, drones or fixed wing, or helicopter. So in keeping with the focus of this conference, I'll talk first about spray buffers for streams and a little bit later for water intakes. So for ground-based applications of herbicides and other pesticides, there's a 10-foot buffer. And for applications by drones or fixed wings, the buffer is 60 feet. All these buffers start at the average high water level of the stream or other water of the state. Side note, drones and fixed wing applications are presently fairly uncommon, although I foresee growing use of drone applications in forestry. There's a lot of folks that are experimenting with drone applications and seeing how they might work in a forest environment. Okay, so early on I mentioned Senate Bill 1602 as the latest installment of updates to Oregon's forest protection standards. The Senate bill put in place new or wider buffers on some streams and new buffers on water intakes. And these apply to all herbicides and all other pesticides that are applied by helicopter. And so those buffers are for domestic and fish streams, the wider of 75 feet or the harvest RMA width, and harvest RMA widths on the largest end are 100 feet. So the spray buffers are 75 feet to 100 feet, depending on the stream type. And then for non-domestic, non-fish streams with surface water at the time of application, the buffer is 50 feet. And these buffers apply to each side of the stream separately. Fungicides and non-biological insecticides get 300-foot buffers, but forest applications of fungicides and insecticides is super rare. I didn't create a slide for it, but there are buffer requirements for fertilizer applications as well. Those buffers are 100 feet, 100-foot setback for any domestic use stream, and other waters of the state don't have a specific buffer requirement, but applicators are required to keep the fertilizer out of the water. Okay, so for water intakes, the buffers are 300 feet around the intake itself. And this is a new buffer to our forest practices rule suite. And this is a result of the Senate Bill 1602 that I mentioned. The Senate bill identifies the water uses that the 300-foot buffers apply to. So they apply to water intakes for domestic use, lawn and non-commercial garden, livestock watering, and municipal water systems. So these buffers will take effect later this summer after the Ferns electronic notification system that John referred to is built and ready to bring these water intakes into the system for protection. Okay, a couple of other water protection measures of note. Mixing and staging areas for pesticide applications must be located away from the waters of the state, and there are specific setbacks for aerial applications. Also, aerial applications next to domestic fish and other waters of the state must be made parallel to the water. That allows much greater precision in protecting the water. And then there are bare minimums as well. Regardless of the spray buffer, any riparian vegetation that's required to be retained by rule must be maintained. So that's a backstop, as well as the label, of course. And that's the intent of my graphic there with the triangle, the pyramid, you know, the EPA with its FIFRA law, Oregon's Pesticide Control Act, Oregon Department of Forestry's Forest Practices Act, and now on top of all that, Senate Bill 1602. And all these rules and laws are additive. So the most protective of them all is what applies. Okay, and lastly, in the way of communications, so for community water systems that are less than 100 square miles in size for their watershed upstream of the water intake, the applicator must inform the community water system manager of any ground applications within 50 feet of the domestic use stream within that watershed, and 100 feet is the notification hurdle, communication hurdle for aerial applications. Similarly with individuals, Oregon Department of Forestry's e-notification system is presently being built to allow folks to register with the department to receive notifications about helicopter applications of pesticides within 1 mile of their home or their surface water intake. So there are communication standards and opportunities presently and being built within the system. Okay, that was my last slide. I understand we're going to take questions at the end. Is that right, Mike? But feel free to reach.
That's why I'm cutting you off here. So we'll take questions at the end for the panel.
Okay.
Excellent, Jay. And you made it through them all on time. That's pretty incredible. So next we have another forester. Whitney Henneman is a third generation forester. She works for Silver Butte Timber Company in Riddle, Oregon, which is the forest management arm of C&D. And she is a reforestation forester. So Whitney, please join us.
Yeah, thanks, Mike. Thanks for having me. I'm glad to be here. So I'm a forester for Silver Butte, like Mike said, and I help manage timberland in Jackson, Douglas, and Coos counties in Southern Oregon. I've been a forester for just over 10 years, managing timberland in Southern Oregon and Northern California. And when people ask me what I do, really the simple answer is that I grow trees. I'm lucky to work for a company that allows me a variety of job titles, but on the days that I am wearing my reforestation forester hat, I'm a tree grower. Let's see. Uh-oh. So much like my brother who's a rancher, I'm not necessarily focused on tree growing. That's up to Mother Nature. But as my brother often says, that he's in the business of grass growing and not cattle farming. No grass, no happy cows. And quite honestly, the same goes for forestry. My goal as a forester is to grow a recently harvested area into a new forest as quickly as possible. So in the first several years of a forest life, I'm not growing trees per se, but controlling the competition. So nearly half of Oregon is forest land, and 80% of this forest land is classified as timberland. And private sector foresters are tasked with growing trees for production of timber, but also practicing sustainable forestry. We care about the long-term status of forests and want forest land to continue to thrive in Oregon. So with all this trees to tap talk, how does someone in the business of applying herbicide fit in? Well, some of the cleanest water in Oregon comes from managed forests, as I think you guys have already talked about today. We follow some of the strictest environmental standards in the world through the Oregon Forest Practices Act, and water protection actually begins long before a tree is even harvested. Jay did a really good job of describing the stream buffers for herbicide, but I think it's important to mention that we also protect water with just our harvest buffers also. So why herbicide? Small, newly planted seedlings are at most risk for competition issues, particularly grasses and brushes competing for important resources in the first few years of life. So the most effective and efficient way to control competition is herbicide. By giving forests an early advantage with the use of herbicide, we can speed the time it takes to develop into a forest ready to produce the sustainable resources we all use. Foresters typically use an herbicide an average of 2 to 4 times per year in the first 3 to 4 years after planting, and then really not again in the entire rotation of the stand. And in Oregon, that could be 30 to 80 years on average. So a typical regime in kind of a managed forest in Oregon, particularly Southern Oregon, first comes the site prep spray. So this is late summer, early fall, post-harvest, but pre-planting. This is an herbicide application that's focused on reducing woody brush and hardwoods before they're in competition with our soon-to-be planted seedlings. And then obviously we plant the trees, and then comes the release spray. This happens early spring post-planting. This is targeted at reducing herbaceous competition that's sure to compete with our newly planted seedlings for moisture in the hot summer when seedlings are growing and needing resources. And then often a second spring spray in the second or maybe third growing season is needed to ensure seedlings are well established, and that's it. Foresters use herbicide as sparingly as possible because it's expensive, and our goal is to help seedlings achieve free to grow status early and to be able to outcompete for resources on their own. So how do we apply these herbicides? Usually in 2 ways. I know you guys have probably already talked a lot about this today, but the first method is a backpack spray. This is most commonly used in areas that are sensitive to the use of helicopter, maybe sensitive neighbors, areas with easy access and gentle terrain, or smaller harvest areas where helicopter use is inefficient. Backpack spraying is costly and timely, but certainly an effective tool for foresters. And then the other most common way herbicide is applied in a forest setting is by helicopter. This method is most used in areas with less forgiving terrain, large areas, and is very accurate with the use of GPS and professional pilots and equipment. Foresters are always mindful of water resources, and protection of water in Oregon begins long before the helicopter leaves the landing. The use of chemicals that we use in Oregon are labeled obviously for appropriate use, and the prescriptions that we use are carefully selected. All of the chemicals we use are registered with EPA for the use in forestry, and the chemicals, before they get registered, go through many years of testing and safety standards before they're ever used operationally. We often use adjuvants and surfactants to help mitigate drift. And then foresters are always on site during the herbicide application, monitoring weather. We're making sure the GPS and the pilots and the applicators are all working well together, and then making sure that the nozzles that are designed to distribute droplet size are working appropriately. We're all kind of in this together to make sure everything's going well there. So really, just to kind of summarize, a forest manager's use of herbicide is that we want to control the vegetation, but follow all of the requirements of the label in the Oregon Forest Practices Act, but grow healthy forests and maintain clean and cool water for everyone's use. Thanks, Mike.
All right, Whitney. Well, you got us back on time. I appreciate that. So you'll get an extra question in the Q&A for your reward. So next we have Carl Morgenstern, and Carl's eWeb work has already been somewhat mentioned, but he is the Water Restoration Program Manager with the Eugene Water and Electric Board. And his job is to make sure that the people in Eugene Springfield area drink the best water. So how do you do that, Carl? Tell us.
Thanks, Mike. Oh no, can you stop sharing your screen?
Yeah, I'm trying to do that. There we go. And now you can start sharing.
All right, I'll do that.
Well, I like that divider behind you. It looks like a Thai restaurant or something. Are you broadcasting from a Thai restaurant?
Yes, it's you wouldn't like to see what's behind that without that. It's an attic.
No doubt.
So yeah, I'm Carl Morgenstern with eWeb. I was the water quality supervisor for eWeb until the Holiday Farm fire happened, and then I got essentially promoted to run the restoration on behalf of Lane County Emergency Operations as part of the Watershed Recovery Task Force. So that's my current job. Most of you know the McKinsey, but in case you don't, here it is, and you'll just observe that our intake is at the bottom of the McKinsey watershed. So everything upstream of that is essentially our source water area. So eWeb developed a drinking water source protection program in 2001 because the McKinsey is the sole source of drinking water for over 200,000 people. We do take it straight from the river into our filtration plant. And kind of the objective and the overall goal of this program was to measure the balance between watershed health and human use over time, and then to implement actions that maintain that healthy balance with the production of exceptional water quality. We are lucky in the McKinsey to have a very exceptional water quality from a large spring-fed river. So in order to do that, basically we look upstream of our intake at what kind of human activities and land use is going on, and then design a program that helps reduce the risk and mitigate those activities that might impact water quality. And so you can see that the light purple there is the industrial, private industrial timberlands. Then you got a large part of the watershed is Forest Service and BLM. And then that valley is agriculture, rural residential, small woodlot owners, and so forth. And so when we look at that activity upstream of us, we kind of categorize it into two major threats. One is the human built environment, which includes development along the river, urban runoff from Springfield, industry that's in Springfield and the outside surrounding areas. And then of course hazardous material spills from Highway 126 and other spills. But the other big piece of this is kind of the natural resource side of things that's also poses a threat. With the human built environment, basically all you can do is once that environment is built and used, you can just try to mitigate the impacts. But when you look at industrial forestry and agriculture as threats to drinking water quality, in these cases, you can actually work with the landowner to increase buffers, get cows out of the river creeks, maybe do organic farming. So there's ways that you can actually work with these landscapes, these landowners to lower the impacts or threats to water quality. So this is the study that was referred to earlier. This is one we did with the USGS. It was a 10-year study. We looked at over 13 storms, a couple of baseline events, non-storm events, and ended up collecting a lot of samples for a lot of different pesticides, and trying to really look at the pesticides impacts from different land uses. So this is all basically focused on storm event monitoring of urban runoff and kind of the more rural developed areas, forestry and agriculture. So we did use automated samplers that were triggered with a rise in the stream. And we had flow gauges on the stream, so we knew the volume of water that was flowing through the area. And we also used water quality sondes, which is that instrument you see on the next to the flow meter that measures turbidity, conductivity, pH, DO, temperature, and other things real time. And so when we looked at urban, basically there's a lot of things coming off roads and cities. And so you have metals, fertilizers, paints, petroleums, and pesticides. And so when we looked at trying to isolate that, basically we monitored the 5 stormwater outfalls that are above our intake, plus tried to do upstream, downstream of those to get a better sense of the impacts from urban inputs. For the forestry, obviously our main concerns was on sediment, pesticides, and fertilizers. So when you looked at how to look at impacts from forestry, specifically with regards to pesticides, we use the notifications, essentially, which John talked about, to identify each year kind of where the most spray activity is occurring. Then we had set up auto samplers at the base of those creeks or basins, and then sample that during the spring storm and winter storms. And so this is we map this every year. It's to 2020. We started in 2001. So we have this data in our GIS. And then for agriculture, basically main concern is of course sediment runoff, erosion, pesticides, fertilizer, as well as fecal bacteria from cattle. And so for this, basically we mapped all the crop types in GIS in the watershed, and then used some OSU typical spray applications for agriculture and applied those typical spray amounts and pesticide types to the polygons for that crop. So this kind of gave us a total pounds per acre of pesticide applied. And then we're able to focus on a couple of areas that had the highest pesticide applications based on the crop type. The problem with agriculture that we found, as you'll see when I get into the data next, is that it is really hard to isolate these floodplain areas because the streams, it's hard to find a stream that is really just draining agricultural areas. So a lot of the ag stuff was picked up in some of the mixed land use, like you see in Camp Creek there, where it has rural residential agriculture, and then in the uplands you have industrial timber. So the results from this study basically showed that we found a lot of compounds, but as John was alluding to, those 19 quantified are those that are above the method detection or reporting limit for the method used. And so those 19 were confirmed. The others are all estimated values, meaning that they were below the reporting limit or detection limit, and that so the lab found it, they detected it, but they could not quantify it. So it was a trace amount that could not be quantified. And so you can see that, the mixed you have ag, forestry, mixed land use, and urban, different colored dots there. You can see the red dots are most prominent from the urban. I tried to arrow some of the compounds that we got more forestry hits than pretty much any of the others. And those were hexazinone, imazapyr, and trichopyr. Obviously, we also got forestry hits of atrazine, 2,4-D, and others. But I just tried to highlight those that seem to have more forestry associated with them than the others. And then another way to look at this is basically for each storm event at each location, we summed up all the pesticides detected at that location and then put it in a graph by land use. And so you can see that, and obviously like the last table and this one, it is a log table. So it's not, it's an order of magnitude as you jump up. But you can see as you go from left to right that basically the one thing that is changing is the number of development homes that are on the landscape. And so you go from agriculture and forestry, and then you get into mixed rural residential and then urban. And so you can see a nice trend there that as you go to the right, you are having more pesticides found at higher concentrations. And so from this study, basically, we realized that urban and to a less degree ag pose the greatest risk. Now, before we did this study, basically we were looking at forestry as a medium to high risk just because of the number of acres that are sprayed each year, and assuming that, well, if you're spraying thousands of acres, we're bound to see that chemical in the water. But I think after this study, what we found is that basically the active ingredient, the concentration of active ingredient that forestry uses per acre is very low when you compare that to what residents use in the city or ag uses. So the concentration, the amount of active ingredient you're applying per acre is much higher in those land uses than in forestry. And so that kind of brought us, that's that study. And then what I did is wanted to add, obviously we're continuing to monitor to this day. This gets us up, adds 7 more years of data to that study. In the last 4 years, we've really been focused on urban runoff. So I haven't done a lot of forestry monitoring in the last 4 years. But so when you add up the last 17 years of data, this is kind of what it looks like as far as the number of detections we're getting by analysis. And then you see hexazinone and trichopyr, which were the ones I highlighted before, are in that top 10 list, so to speak. But you can also see the concentrations that we have, like a hexazinone is 0.09 parts per billion, which is fairly low. That one fairly large trichopyr hit, 3.1, that was actually because we monitored below a resident who had treated their blackberries. And so we went back and monitored and had a much lower number in the subsequent. And then this is looking at it by stream type. So you have stormwater channels, tributaries, and the main stem is the blue. And a solid dot is a confirmed hit by the lab. A open circle is a estimated value because it's below the detection limit. So just looking at this visually, first off, you can see the MCLs are very far and few between, as I mentioned earlier. And most of the results we have are orders of magnitude below MCLs. But you do see that stormwater is clearly a concern as far as pesticides in the water. The other thing to note here is that the blue dots, which is the McKenzie River, there's just a couple of hits, one of atrazine, another of sulfametronine methyl, which was mentioned before. And then most of the others, and then a diazinon hit, and the rest are a few scattered estimated values that were found in the McKenzie. But for by and large, the McKenzie is a very clean river, I think, partly because we're looking at dilution of whatever comes into it because it's such a large spring-fed system. So kind of our conclusions from monitoring over the last 20 years or so is that urban runoff and high-density rural developed areas have the most types of pesticides, and highest concentrations that are detected more frequently. And then as you get into basically the main stem, you have very infrequent and trace levels of pesticides found in the river. That's really because of dilution from spring-fed system. And because of this, basically our priorities for mitigation and addressing these issues really are focused on urban runoff, development along the river, and agriculture. It's not that we don't work with forestry. It's our priority shifted given the limited amount of income and revenue we have to put to these issues. And so you have to go with the highest priority work first. And we do collaborate with forestry quite a bit, especially around wildfire prevention and response, and are doing some other efforts right now with some of the industrial timber folks after the fire. One of the concerns we do have after the Holiday Farm fire is that a lot of salvage logging is currently happening across the watershed, obviously. Almost 173,000 acres burned, the vast majority of that industrial timberland. And so you're seeing that basically all this timber is now in the same age class. It's all getting replanted at the same time. And so you're going to have a lot more spraying happen in these early years because everybody across that acreage is going to have to deal with having the same age trees growing up and then trying to reduce competition for those seedlings. So we are really concerned about pesticides moving forward post-fire. And I think that is all I got.
Excellent. Thank you, Carl. I'd asked John and Whitney and Jay to come back, and we don't have a lot of time, just a couple minutes. And if you could stop sharing, Carl. Thank you, thank you. So I'm just gonna, one of the beautiful things of having a workshop in Zoom is people see the questions as they come in and they get answered. And I was really stumped by Edie's question about the mycorrhizal and the microorganisms, and it was a great answer posted by Megan. So I read the abstract of that article, and I think it does it well. And Whitney was able to correct a question. So I just have my question, and this is my favorite way when you get a diverse panel like this. I like to ask the same question and have you each take a shot at it from your angle. So I'm going to start, I'll ask the question, and I'm going to ask John to take the first shot at it. Since he had the most time to talk, it's only fair that you all have more time to think. So one of the things that we talked about, John mentioned it, Jay mentioned it, Whitney mentioned it, and Carl almost mentioned it. And it was big in the earlier panels today, is communication. Jay also talked about the changes in the forest practices rules. John talked about the notification of operations. One of the other things that's in Senate Bill 1602 is a real-time notification of operations. So that the idea is that a water user, a neighbor, somebody else would know when it was actually applied, what was actually applied, and that kind of stuff. So from each of you, from John, from the science, Jay, from having to do this practically, with the Department of Forestry, Whitney as a practicing forester, and Carl as a water user. What do you guys see as the pros and cons of this? And is it as big a thing as I think it is? So we'll start with John, Dr. Science.
Yeah. So I think that the reporting piece of SB 1602 is a big improvement, certainly compared to past practices for it. I'm not convinced that it necessarily provides a bigger picture of what chemicals are being used in forestry. And so if we don't have existing process for reporting chemical use, whether it's in forestry or whether it's in agriculture. So we don't really have very good information on the aggregate amounts of chemicals that are being used statewide.
Okay, like under the 2007, 2008 PURS, something like
Yeah,
that.
yeah.
Good answer. I like that. Jay, how are you guys going to deal with this?
Yeah, well, I'm glad that you asked that question. So when a forest operator, forest landowner plans to apply herbicides to their forest land, they're required to notify. And John harvested a bunch of interesting data from those notifications. And part of that notification process includes listing out all the chemicals that they think they might use on that particular operation. The Senate Bill 1602 that you mentioned, Mike, several of us talked about it. It hones in and tells folks, hey, whatever you're going to plan to use out there, notify for it, but don't notify for anything that you're not likely to use out there on the landscape. That there are no requirements for post-application reporting, but as far as the communications part of the Senate bill, yes, when somebody's interested in what's going on around them, they can register through Ferns, the Forest Activity Electronic Reporting and Notification System, to receive communications about planned pesticide applications to be applied by helicopter that occur within 1 mile of their home or their water intake. And so when they go through that registration process, they'll get copies of those notifications shortly after the notifications are submitted to ODF. They will also receive next day announcements, which means they will know by 7 o'clock the day before, 7 p.m., the day before the planned aerial application, helicopter application, that the applicator plans to conduct that operation sometime the next day. So they can use that information however they wish. And then the bill also requires the applicator to report whether they completed the unit, completed the spray operation, or didn't complete it. And so that information is also available to the registrants.
All right.
So yeah, Senate bill
That's a lot of information. So Whitney, how is this going to be in practice for the forester on the ground that's got to make this happen?
Well, Mike, that's a good question. We haven't had to work through this yet. We're starting, we're heading into spring spray season now. So this will kind of be our first run at these new rules. I think that, I think it sounds really good. I think that the neighbors or the people who subscribe to these notifications are going to be really frustrated once they start to kind of see the communication that they receive from either the forester or the applicator. Because, often like that 7 p.m. notification the day before the the actual application takes place is going to be kind of a CYA, because, with helicopters, weather changes, plans change, we break down. I mean, there's a lot of things that contribute to not spraying not sticking to the normal plan. So I think that we're going to probably be over communicating with a lot of these subscribers to begin with, and we probably will have some kinks to work out. So I think that that's probably going to be the biggest frustration we're going to see from.
Good, thank you. And last, Carl, as a water user, big water user with a lot of spraying happening, are you going to love getting all these notifications every day, all these calls at your house at 7 p.m.?
Actually, when you look at it, if I was to pull up that map that I showed you guys earlier, if you drew a mile radius around our intake, you would hit a little bit of forest land, but it'd be mostly ag, urban, and just a little bit of forest land. So all of our timberlands are in the middle part of the watershed, which is miles upstream. So I don't, I'm hesitant to even, apply to it because I'm not sure it'd be worth it. I probably will just see how the system works. But
All right.
yeah, so I think it doesn't do a lot for us. Obviously, other water users, it's probably
Right.
a big bonus.
Fair enough. Well, we are out of time. I'm going to thank you all. Thank everyone for hanging in there. I got 2 messages to close out the day. Number 1, the secret word is trees, as in trees to tap. So that's, if you're getting the SAF credits, that's the word you need to put in your secret word line. And then the other is we start up again tomorrow morning at 8 a.m. We'll have the Zoom room open at 7:30 for people that like to come early and look at me. But I really want to thank you all of the speakers, all of the facilitators, all of the moderators. This has been really good. The high point of the day, people-wise, was we had 138, and there's still 76 of you that are hanging in there, but you're dropping like flies. So it's after 5 o'clock. So thank you all. See you back here tomorrow. Good night.